Hello, today we talk about the myths surrounding engineering design 3D software. I'm going to introduce you to what they call parametric design and design intent. All 3D software and engineering are use the same principle around parametric models, which are feature based. We'll talk about this later. And they also use design intent, which determines really how you want your model to behave in the future. So looking at this bollard, I designed this bollard in different materials, as you can see here. And then to be able to make a good design, we have to use a good design intent, as we would say, because there are different materials: steel, carbon, and rubber. So smart tools and parametric design is what is now in the future. The old style is seen in this telephone, whereby shapes have been used, predictable shapes, which we call the primitive shapes. In here we've used two of them, the cylinder and a cuboid, in order to get that telephone. So this is a very simplistic way of drawing using Boolean operations. Now, if you look at these designs here, on top we have the old designs, and below we have the new designs. The new designs do not quite focus so much on the Boolean operations. They go into a bit more complex designs, which are not defined by existing shapes. And this is where parametrics become very important. Same thing you can see here, different designs. The water bottle you see here the milk bottle for children is designed in a shape which is convenient to hold, but which the old ones were a bit straight and easily predictable. But it's more comfortable to hold and a bit more complex. The same with the coffee press you can see there. And the same with that kettle you see at the bottom right. So what is parametric? Parametric is used to describe dimensions, the ability of a model to change using dimensions. And this is true for all the software you see at the bottom here. It is true for all this software. It is also true that all this software can produce what is called feature-based components. Various features such as holes, grooves, fillets, chamfers can also be generated by any of this software. A good example of design intent is what you see here on the screen. There's an original part with a boss in the middle, and then when the hole was shifted to the top, the whole boss went with the hole, showing a good in design intent. But you see here in this one, the hole does not move with the actual boss. So this is not a good design intent. So for this reason, you can see that the closer your design implementation is to your design intent, the greater the integrity of your model and even how you can manipulate future drawings. So what do we look for when we're looking at design intent? You have to look at things like symmetry. Anything symmetrical can be revolved, can be mirrored. So symmetry is very important. Which way up? If you're designing a car, the wheels should touch down. Some people say, no, we can keep flipping it, but that doesn't make any sense. It just wastes time. How could it change? And also, actually, sometimes it may not work very well when you go to other machines like CNC and the rest. How could your design change? Like, for example, iPhone has so many versions, iPhone Plus, iPhone Pro. I don't think that they do design each and every phone without just improving on a standard model. Will it have multiple variants? If you're designing a bicycle, you may have so many sizes, size 16 for children and size 24 and above, even for bigger people. So does it mean that these people need to keep designing every bicycle, or they can use one design and then scale it up or scale it down? So in any design, all these must be considered. And this takes us to the point that most of these parametric software, Fusion, SolidWorks, Creo, whatever, are not for drafting, they are for design. So we need to use them with that approach of design rather than just drawing an engineering component. You need to understand the purpose of the model, any anticipated potential requirements to redesign, and any future considerations on that very design. I'll touch a bit about how parametric designs work. The sketch is the basis of all 3D models. So to produce any 3D design, you must have a sketch. And that sketch is in 2D. Some people actually say that to do good design in 3D, you may have to start with some software like AutoCAD to understand the tricks around creating a good sketch. Okay? And always these sketches must be made on planes, plane faces, or other planes which you can create, as we shall see in another video about software. So in all this software I've told you, you're going to see these colors when you produce a sketch. A sketch which is fully defined will be black. A sketch which is lacking something is going to have some blue lines, and a sketch which is over-defined is going to show some errors. So please, these colors you see on the screen can be in any of the software I've talked about above. And that's my strong reason of saying that these software are the same. Now, constraints and relations. In all these software, you're going to find these symbols. That one means vertical. That one means horizontal. That one is tangential. So this curve is tangent to that line. And then that one is concentric, which means that this hole is concentric, have the same center as that, and this curve here has the same curve as that. So you will find this in most of the software, these constraints and relations. Then for all this software, all you have to do is make a sketch. In this case, we are creating a sketch out of this shape. The sketch is black, and then you just do an extrude, and that you can do in any of the software. which we talked about. Okay, so I leave you with this drawing here. I'll put the dimensions. Just try it out and see that you use a good design intent to make sure that you've separated it well and it makes sense. We may have to design this one in another video, but this is just for illustration, which I give you as an exercise. Okay, so now we are champions of parametric modeling. We don't have to fuss so much about different software. Most of my videos will be coming in Inventor and Fusion, and at some stage I'm going to introduce a bit of SolidWorks, and I'm going to do the same drawings using different types of software. So what do we benefit from this? You can make automatic updates of the model using software. You can capture design intent by separating the different levels like we saw on the bollard, and then you can create families of parts which you can use in other ways, and then you can also integrate manufacturing processes and other downstream activities in all of that software which I've talked about